So please welcome to the stage Edmund Edgar from Reality ETH.
Good morning, thanks for coming in on this filthy morning in Berlin. Since it's DappCon, I want to talk mainly about stuff that we've built, stuff that we shipped, stuff that you can use right now to make your dApps better. And then if I've got some time at the end, I want to talk a little bit, first to do a little bit of kind of conceptual stuff, and then talk a little bit about what I think is quite an important thing that we're trying to build next. So I'll just say a little bit about myself, if I can make the slide go. Turn it on, might help. Okay, so back in about 2013, I was reading about smart contracts and the Oracle problem on Bitcoin Talk, but there were no oracles, so I built what was the first smart contract oracle, Reality Keys. And back then, I kind of saw the problem, like a lot of people, some people still do, as like, how do we kind of bridge to APIs and websites? Like, how do we get trusted information that we already have on the internet somewhere? And how do we get that to the blockchain? And there are a lot of really good projects now that deal with that problem. But I also saw that a lot of the most interesting use cases involve actually creating information, right? We need to actually get people, we need to get information from humans. We need to be able to ask questions and get people to give us the right answer. So that's what this project is all about. So this is Reality ETH. We've got our own dApp front end, but a lot of the apps that use it have their own front ends for the way they use it, talking to our contracts. What we're trying to do here, we want to be able to handle any question with like a publicly available answer, right? So anything that humans out there know, we do it just with the blockchain. There's no IPFS for reasons that I will explain. It's deployed all over the place. It's on mainnet. It's used a lot on Gnosis chain. It's also on Arbitrum, Optimism. Pretty much any free software chain will put it on. We're not doing Starknet because that's proprietary, but pretty much everything else. It's designed for fairly low gas usage. So we reckon you shouldn't have to take more than like 100,000 gas for anything. There's no admin keys. There's no governance. There's no token. It's a contract. And it's cheap to use, and where we do have to make some humans do some work, where we have to actually create some costs for somebody, the idea is that we want liars and idiots to fund that process. So let me tell you a bit how we do it. So it's based on a fairly simple economic game. Anybody can ask a question. When you ask a question, you can put up a reward if you want to for the answer to that question, but most of the time we find that people don't need to do that. When you answer, you post a bond. That then sets a clock ticking. So this is something that you decide when you set up the question, how long it's going to be. So usually 24 hours, something like that. And then in the happy case, probably about 98% of cases or 99% of cases, the first human to answer the question is honest and correct. So what's going to happen is the clock's just going to start ticking, say it was 24 hours, and in 24 hours it's finalized, and then that's the final answer. But in some cases, somebody may see that they've put in an incorrect answer, and what they can do is they can change it to what they think the answer should be. But when they do that, they have to double the bond. And doing that is going to set the clock ticking again, goes back to 0, and then that can carry on as long as you like. So in theory, you can keep on extending the time. But every time you do this, you're doubling the bond. So fairly quickly, we're going to get to the point where no people are going to have more money than they're going to want to put into the system. So in of the cases where something is contested, the vast majority are going to end like this. The clock's going to tick down again. Nobody's going to challenge, and that's the final answer. But you're probably looking at this and thinking, okay, but then the person with most money is just going to be considered correct, and they're going to win all the previous bonds. So we then go to the Arbitrator Contract. And this is designed with kind of the sort of a money Legos approach. So you can plug in whatever mechanism you want to do arbitration. The most common one right now, as I mentioned, is Kleros, which is a really nice fit with kind of an internet court system. But anyway, what happens here is that you're going to pay a fairly expensive fee to request settlement. When you pay that fee, that freezes the question, and we then wait for the arbitrator to rule, right? So the thing about the arbitrator is this can be a really expensive process, it can be a slow process, and it can be kind of a socially expensive process, right? It can be involve a lot of people coordinating. Now, we are seeing some cases recently where people do the thing successfully without an arbitrator, especially if they're using their own token for the bond, and they're trying to get a decision on something like, how did this snapshot vote go? Because a lot of the time recently we're seeing this used in governance. There's a very nice sort of Gnosis snapshot integration with Gnosis Safe. So some of the time, if you're just trying to get effectively a majority vote of your own token holders, then you can assume that if you're just trying to see what your token holders voted on an off-chain system, then probably half of once you've got, like, the maximum bond you can get is going to be half of those tokens, and that represents the judgment of your token holder. So in that situation, people aren't using an arbitrator, but most of the time you do. So how do we do arbitration? There's a bunch of ways. You could use trusted third parties. I mean, there's a lot of stuff being used out there that does. If you've got a token or a DAO, you can have them vote. Again, very socially expensive process, very slow process, but that's okay because it's only used in these very exceptional cases. And then what we're seeing, really used a lot. So, for example, Omen prediction market was using this, and a lot of dApps right now are using this. Is Reality ETH plus Kleros, using Kleros for arbitration. And Kleros have this little adapter, which means that even on a chain where you don't actually have Kleros, even when you don't have the Kleros arbitration system on the same chain that you're operating on, we can still switch over to the main chain to pay Kleros and then send a message back to whatever chain you're on to get the judgment. And again, that's an annoying thing to have to do, to switch the chain, but it doesn't matter because it's hardly ever done. It's only done in exceptional circumstances. If everyone was kind of rational and self-interested and wise, I mean, they're stupid, but if everybody knew what they were doing, then this would never happen, right? Game theoretically, you should never even need to call the arbitrator as long as they're there. But in practice, it happens occasionally. And then finally, I'll talk a little bit about the thing we're building with kind of a forkable layer 2. So I'm just going to go back to nuts and bolts a little bit and talk about how you actually ask a question. So you can put your question into the DApp if you want to. That's one way to do it, or you can send it from your contract. And when you have your contract do it, you're going to pass in the template ID. I'll talk about that in a sec. Some text, the arbitrator address, the timeout period for how long it's going to take after somebody gives an answer that somebody can contest it before it's finalized, and then a couple of other things like the minimum bond and stuff that you sometimes want. Then you want the answer. When your contract wants the answer, it can call one of these two methods against it. So result 4 is the simple one. This is gonna, if the question hasn't been finalized yet, then it's just gonna revert and do nothing. But if it's been finalized, then it'll give you the correct answer. And then what we added recently, result 4 once settled, this does something similar, but sometimes you don't know when a question is going to be settled, right? So let's say you might be doing a sponsored walk and you're saying, okay, did I complete the sponsored walk? Because if I completed it, you want to be paying me the money. And maybe it rained on that weekend and the thing got put off by a week. You don't want to just have to close the whole thing down. So what we've done is we've built a thing where you can answer that this hasn't been settled yet, and we'll reopen the question. And all of that is handled inside the Reality ETH contract. So all your contract has to do is just to know that it has to call result 4 once settled. And if it's not ready to answer that yet, then it's just going to revert. And if it's answered, then it's going to give you the answer. Okay, I'll just say a very little bit about how these questions are formatted. Just give me a sec. So a question in our world is this kind of chunk of JSON. Looks like this. You've got a title with some text. You've got like a type of question, like a yes/no question, or it could be a bunch of options for a multiple choice question. You may have a category and a language and some other stuff. It's separated into templates and parameters. So the most common thing you do is you've got a kind of some built-in templates like this. So you've got most of the text is in this kind of pre-registered little document. And then you've got some placeholders, so you just pass in text that's going to fit into those placeholders. So let's say we're doing an insurance thing. We want to ask, was this flight on this date delayed by more than 3 hours? You'd pass that text in. So the initial setup would do this bit, and then every time you ask a question, you do something like that. But that's still a little bit kind of wasteful. We're using a little bit more gas than we need. So instead, we can do it this way. You can create a template yourself. So if it's flight insurance, we're asking the same question over and over again, except for a couple of little things that are different, just the flight number and the date. So you can just call this once to create your template, and then every time you want to ask a question, you can pass in the flight number and a little separator character, and then the date, and then that'll do it for you. Okay, so we're dealing with humans, so there's a lot of ways they're going to screw it up. The first problem is we need to have an available blockchain, right? We have a liveness assumption. Generally, so if you said that you can contest an answer within 24 hours, then the blockchain has got to be available within, during that 24 hours, which is normally not a problem with Ethereum or Gnosis chain or these kind of regular layer 1 type systems, but it could be a problem with some layer 2 systems. They don't always have that promise, so you need to work out to watch for that. If there's a lot of ambiguity in the question, that can kind of mess things up. Humans will come up with kind of tricky questions. You need the information about the question to be available. So earlier I said there's no IPFS involved in this. There are some situations where you might be able to ask a question and then withhold and just put in the IPFS hash and then withhold the content of the IPFS document. And then put in an answer, and nobody can contest that answer. There are some situations where that's kind of safe to do, depending how you're using it. Other times where it's not. So I don't know. We prefer just not to do it. But finally, of course, we need the arbitrator to be secure. So, like I say, we've had a lot of people using Kleros, which is a very nicely built, fairly robust system. We had a question that was escalated to Kleros about who won the US presidential election. We had some people who thought it was Biden and some people who thought it was not clear. Kleros, I think, correctly managed to resolve that one. And so I think everything I've said up till now is all about kind of how you use the thing. What I'm going to say now is a little bit conceptual, and then a little bit about the thing that we're trying to build, which I kind of think is important, and I'm looking for people to kind of collaborate with on this. So the basic kind of models that underpin most blockchain systems, and a lot of systems built on top of blockchains, I guess we can kind of think of these sort of types. So you can have sort of purely economic systems, kind of basic sort of majority vote types of systems, which is a lot of DAO governance right now, right? A lot of DAO governance is you've got a bunch of token holders, and 51% of them can decide what's done with what the DAO does. A slightly more sophisticated thing you can try to do is to add shelling games, which is also kind of what Bitcoin does and what Ethereum does, and also what Kleros does, where you're trying to replace the assumption that you have 51% of economic power being honest. You can improve that assumption and say that 51% of the economic power has to be honest and not cooperating and not collaborating with each other, right? So it's okay if you have a majority of like selfish, profit-oriented people, as long as they're not all collaborating with each other to be selfish. But the really firm underpinning of Ethereum and Bitcoin and a lot of these systems is social, what Vitalik called subjective democratic. So we've been discussing this recently in the Ethereum context, talking about what happens if stakers start to censor the stake, right? Start to censor blocks. So we're saying we've got like Kraken and Coinbase, and these guys seem to have a lot of staking power, and potentially they could be, regulated and forced to apply like OFAC sanctions or something. And what we do in that situation is we would go to the subjective layer, we go to the social layer. We fork the blockchain effectively into two. We would make a new version on which, say Coinbase or whoever it was, whoever is censoring the blockchain, those guys are going to get slashed. And then we're going to have like an open version where, well, they're going to presumably, or they may continue to run an open version. Oh, sorry, we're going to have an open version with the slashing, and then we're going to have like the OFAC version without the slashing. And then we can just see what the market wants to do. And the thing about this is, firstly, we hope that the market will favor the open version, right? But they may not, and even if they don't, even if most of the market cap goes to the OFAC version, and the ticker, most people consider Ethereum to be the OFAC Ethereum, and open Ethereum is like the free Ethereum is just some weird like niche anarchist thing. At least we still have our working blockchain in that situation, right? So what we'd really like to do in this situation where we're trying to arbitrate truth is we'd like to fork Ethereum, right? We'd like our underlying blockchain to be able to fork and say, this arbitrator made a decision that was bad. This arbitration has been captured. Therefore, we're going to remove that arbitrator. And any questions they've arbitrated, we're going to just put back into a pool for another arbitrator to handle. Now, we can't fork Ethereum over this. But what we can do is we can make a layer 2 ledger, and we can fork that. So that's what we're working on right now is we want to take something like ZK Sync, probably ZK Sync, but a layer 2 system, make a clone of that system, and then if you issue a token on top of this ledger, or if you have like a DAO, if you have governance on top of this ledger, it can always resort to this ultimate kind of root of truth. People, like, if anything is captured, we can always fork that ledger and carry on with an honest ledger. And hopefully that honest ledger will also be the one with any other valuable assets on it. Okay, so that was what I'm working on. There's more information on the site at reality.eth with your favorite gateway, ETH Limo, whatever you like. I'm Edmund Edgar on Twitter. I basically live on Twitter. So if you've got any questions, anything I can help with trying to use that system, or if you're interested in the thing about the subjective ledger and you'd be interested in collaborating on that, please give me a shout. Okay, thanks, sir.
Thank you, Edmund. Can I ask the first question because I have the mic? How do you incentivize people to come and participate in this? Like as a user, what's my incentive to come and? So
ultimately, the incentive is that if you put in if you correct something that's incorrect, then you can make money. That's the main reason to do it. But what happens, and if you're trying to get a question answered in the first place, and once there's a bond in there, there's an incentive for somebody if it's incorrect to correct it. But right at the beginning, we have the reward that you get if you need to put that in. Now, we find that most of the time, the people who are using this are actually interested parties, right? So people have got something that they want to settle. So usually the person who's finished the sponsored walk and they want to get that money moving, usually they will put in the correct answer and then nobody else will challenge. But if you want to, you can use it as this kind of general purpose fact-checking system where you want to know something, so you put in the money and you get the answer.
Fair enough. Any other questions? There is one over there.
Yeah, so is there any validation on the questions themselves? Because how do you avoid to people to turn into something like an assassination market?
Yeah, so it's an open blockchain and it's got composable parts. This system, since it has no governance, this system cannot govern what kind of questions people ask, right? And even in the assassination case, the problem in trying to, even if you made a DAO and tried to regulate this, the problem in doing it is that you don't actually know what people are using information for, right? So if you want to know if somebody died, it may be because they've got a perfectly legal life insurance contract, right? You don't know. Now, the arbitrator may have some terms about what kind of question that they will arbitrate. So I can't remember, but I think that Kleros has some kind of ethics rules about, certain kinds of question that they will not do. So it ultimately comes down to that. And when you're playing the reality ETH game, you're effectively like betting on what the arbitrator would do. So if the arbitrator is saying, we're not going to answer questions about rabbits, then ultimately you shouldn't put in a bond with a question about a rabbit.
Okay, and how the application will handle that? There
Yeah.
won't be an answer about that.
Yeah. So what'll happen? There's an answer invalid, which all questions kind of fundamentally have, which is like FFFFF in hex. So when you write a contract that uses this, you want to be able to just put in some code to handle what would happen if you got invalid. And depending on the application, you might want to like void whatever you were doing. You might want to split something 50-50. It just depends on the application.
Okay, thank you.
Room for one more question over here.
Couldn't someone break the system by just basically inputting the most funds into a question? Like if I'm basically the stronger fund holder, then I can just say, okay, this question is right, and every time someone answers a...
That's where the arbitrator comes in.
Okay.
Right. So yeah. So if you do it without an arbitrator, and you don't have some kind of special situation like you're doing a vote of your own token holders or something, then that's exactly what could happen.
Okay.
So yeah, that's the reason for having the arbitrator.
Thank you so much. Sorry, we need to invite the next person onto the stage. So thank you so much, Edmund. Round of applause, perhaps. Thank you, guys.